So, what is differentiability? What does that mean? If a function is not differentiable, that means it does not have a derivative at a certain point. So I'll write that down. So if a function is not differentiable at x equals a, then the derivative is either undefined at x equals a or has differing one-sided derivatives at x equals a. So if we had something like this, where I have a cusp, something like that. On the left side derivative and the right side derivative eventually approach something undefined because we have like a vertical tangent line. That happens like with cusps or with actually this would be a positive infinite derivative if you think about the left-hand derivative with our derivative definition, and this one would be a negative infinity. That's actually when a cusp happens, when you have a positive derivative on one side and a negative derivative on the other side. That's called a cusp. There is no derivative at cusps. Also with corners, that's just when strictly, it doesn't have to be infinity or negative infinity for the derivative, the one-sided derivatives. But if you had something like the square root, not the square root, the absolute value function, let's do it better than that. Here, this is called a corner. Just the left-sided derivative is some negative number, and then the right-sided derivative is some positive number. So this it's classified as a corner. And the two-sided derivatives, the two-sided derivative doesn't exist at whatever x value that point has. Or you could have like a vertical tangent line. So if you had something like where it's like there's a single point where it has a completely vertical tangent line, that just corresponds to a vertical slope, but we know that vertical slopes are undefined slopes. So this one would be vertical tangent line. And those are pretty much the cases, or actually a discontinuity. If there's any type of if there's a hole, or, well, I guess like that. If the function was not defined at a certain point, then of course there's no derivative. So any type of discontinuity means it would be not differentiable. So any of these four cases means that your function is not differentiable. So that's pretty much all you need to know. It's really simple. The only other piece to this is differentiability at an endpoint. We had a definition for continuity at an endpoint, and it's pretty much the same as the differentiability at an endpoint. And so let's consider that. Normally, I wouldn't even consider endpoints because it is an endpoint. You can't take the two-sided derivative. But if we only have a domain from, let's say that's B and A, and we have something like this. I didn't mean to make it that close to B, but whatever. So if we had something like this, then so the domain would be X such that X is in between A and B inclusive. So if we had this, it's pretty much just a definition for what is differentiable. And when the domain is restricted like this, in between A and B, then we would say, okay, yes, since that's filled in, it's going to be differentiable at that endpoint. Excuse me, because you can only approach from the right side. You cannot have a two-sided derivative on this because the domain is restricted. Now, if you had something like open circle like this, all right, now the derivative doesn't exist at A because you can approach from both sides. So in this case right here, you would say not differentiable at A. But that would be without this domain. If you had this case with this domain, then you can say, okay, it's differentiable at A. Hopefully that makes sense. It's just semantics. It's just like a definition thing. So hopefully that takes care of any endpoints that you have. If it's in the middle of your function, then you're going to have to try and take the two-sided derivative using that derivative definition. But then you would see that it wouldn't be like if you had any type of discontinuity or an endpoint like that on the inside of your domain, then wouldn't be differentiable. But here we would say yes, this function is differentiable at A and B because the domain is restricted there. Like you cannot approach it from this side, you cannot approach it from that side. That's really all you need to know for this. It's a real short section, and we're going to be moving on.